Hello everyone, welcome to our presentation. In this conference, we are going to present our work, COLAS, an enhanced AI-powered programming lab assessment system to ensure automation and fairness using an adaptive LLM and metric-driven evaluation. COLAS stands for Coding Lab Assistant, a web-based system to ensure fairness, bring automation in programming lab assessment to ensure a better learning experience for students, and to ease the workload and quality for instructors. In the current insurgence of AI, it has become a challenging task to conduct programming labs, as the students often opt to use LLM-based AI tools instead of giving an honest effort to try. Besides this, copying from different sources, which we often regard as plagiarism, is also a crucial source of the problem to ensure integrity. Another very hectic task comes from manual one-to-one evaluation through Vivas in our traditional lab setup. To address all of these aspects, we have been working on COLAS. COLAS enforces a strict evaluation platform, provides a robust plagiarism detection module, suggests an LLM based learning trajectory for the students with real time performance feedback, and automates the evaluation process for the instructors. We want to build colas for the educational community for a wide range of utilities to serve as a tool for a better learning experience both for students and instructors. In general, the modules of colas can be divided into three parts: before, during, and post lab periods. Before the lab, instructors can generate newer and interesting problems with the help of colas. Using LLM, they can design new problems, descriptions, and solutions. We also provide utilities to ease the burden of generating test cases using LLM and block-based programming. During lab, the main actor are students. Using the built-in code execution module, they can write code, judge their solution, and get feedback regarding their accuracy. We have also developed a strong activity tracking module. Students are bound to stay in the platform of colas for the whole evaluation period. However, if they leave the application in any regard or use any other application in parallel, they are flagged and reported to the instructor in the post lab period. After the lab, COLAS generates a bundle of analytics to reduce the workload of the instructor. Instructors can get the relative scoring for each problem for each student. Using the built-in plagiarism detection algorithm, they can generate a similarity score for each submission for each student, potentially flag the suspected groups of students who might have shared the codes. Using the report generated from the activity tracking module can detect the students who possible opted for unfair means. They can also get an LLM based report to have an idea of the thinking and solving process for each student for each problem. These reports would enable them to pinpoint the strength and weakness of each student in approaching lab problems. Finally, we also provide support for constrained programming, where instructors can fix a certain type of programming paradigm and test the learning depth of a student. In that, for example, they can say the students have to use single loop for a given problem. The submissions that violated that will be detected by colas automatically. Now we are going to present a report on our performance. Here we show how the scores for each student will be reported via the score accumulated from each problem with the number of trials. For each problem solution, we can also get the maximum core similarity score with, with other submissions denoted as the last row in the image. For each problem, we can get a detailed report on the similarities observed with the other submissions. Here, three high similarity scores are tracked with the red boxes. As shown through the code fragments, our solution captures both structural and textual similarity. As you can see from the image, two submissions are almost identical with just the variable names have been replaced. Here, we present a snapshot of the performance on the activity tracking module. We can detect any unfair means from leaving the application to using multiple applications with a fine grained timestamp, embedded granularity import. As we mentioned prior, through LLM based technique, Combined with our algorithm, we generate a report on students' thinking process and solving pattern. The reports help us to formulate the students' strengths and weaknesses, which can guide in designing personalized training plans. Using AI prompt, the instructors will be able to modify and write newer problems descriptions easily. Such automation will help them to focus more designing newer interesting problems. From our ground reports, we are able to reduce around 2 hours of time for each lab for an instructor, where a significant amount of time was bound into manual effort that now can be replaced via COLAS features. In the surge of AI, educational tools have become quite widespread. From the piloting and grounding report through the deployed labs, COLAS has been found as a very useful tool helping both instructors and students. We have also attached a live demo of our work in the slide for your reference. So, in summary, COLAS is automation tool that provides strictness with a bunch of interactive tools and students and instructors. COLAS is a completely web-based app which can be accessed from anywhere in the world. The front end of COLAS has been developed using React.js. The backend of COLAS has been made with Python-based Flash framework. We have kept the dependency on the third-party libraries to the lowest, maximizing the usage of low-cost infrastructure. Lastly, novelty of COLAS is that there are some existing solutions. However, as per our knowledge, COLAS is the only one that bundles all of these interesting features into one application. We invite everyone to use COLAS and give your feedback to enrich it more. This is the team behind the product. Thank you, everyone. If you have any questions, please visit code.cognistrom.ai. Thank you.